Solve 1 over x minus 6 plus x over x minus 2 equals 4 over x squared minus 8x plus 12. Again, we're going to start by rewriting this equation with denominators factored. There's nothing to factor on the left-hand side. We just have 1 over x minus 6 plus x over x minus 2. On the right-hand side, though, we can factor that denominator. We use the unfoiling method. We're looking for two numbers that have a product of 12 and a sum of -8, and they are -6 and -2, which shouldn't be a surprise because usually in these problems we've got denominators that have factors that are the same. You certainly could have a situation where none of the denominators have anything in common, but oftentimes in math classes we give you problems where the denominators have some things in common. So shouldn't be too surprising. We need to start with the restrictions. If we look at the factors in the denominator, we have an x minus 6 and also an x minus 2. So x minus 6 can't be 0. And also x minus 2 can't be 0. So if we look at these restrictions, x minus 6 is 0 when x is 6, so x can't be 6. And also x can't be 2. If x is 2, then 2 minus 2 is 0. So here we have two restrictions. X can't be 6, and x can't be 2. Let's find the LCD. Let's multiply, and let's solve this. When we're looking for the LCD, we notice that there are factors of x minus 6 in a couple of the denominators. So the LCD has to have an x minus 6. Also, we see x minus 2's popping up. So the LCD also has to have x minus 2 as a factor. And once we have one factor of each of those, we are ready to go. So let's multiply both sides of this equation by x minus 6 times x minus 2. Not the prettiest 6, but we will survive. On the left-hand side, we need to distribute. Notice in the first term, we've got an x minus 6 in the bottom. That's going to cancel with the x minus 6 on the outside. Those go away, and we're left with x minus 2 times 1, which is just x minus 2. I'm going to leave that like that. Then we have plus. In the second term, the x minus 2's will cancel because we've got one in the denominator and one out front. So we're left with that x minus 6 times x. I am going to save that multiplication for the next step just so that I don't do too much at once and make a simple mistake. On the right-hand side, the whole denominator cancels because we've got x minus 6's and x minus 2's in the bottom and out front. All of those cancel, and then we're just left with that 4. So the right-hand side is just 4. Now we can distribute this x on the left-hand side. The x minus 2 out front is just going to stay there. Then when we distribute the x times x is x squared, minus x times 6 is 6x. So on the left, we've got x minus 2 plus x squared minus 6x, and that equals 4. We can rearrange things on the left in standard form, and we can combine like terms. So that x squared is going to go first. When we combine the terms with x minus 6x is negative 5x. And then we've also got that negative 2 on the left, and that all equals 4. Now, we need to get all the terms on the same side when we're solving a polynomial equation. So we need to subtract 4 on both sides. That gives us x squared minus 5x minus 6 equals 0. And now we can factor the left-hand side. We're going to use the unfoiling method. We need two numbers that have a product of -6 and a sum of -5. Those numbers end up being -6 and +1. So this becomes x minus 6 times x plus 1 equals 0. And now we can set each of these equal to 0 using the zero factor property. And we can solve each of these for x. We add 6 to both sides, giving us x equals 6. or for the other one, we subtract 1 from both sides, giving us x equals -1. So our potential solutions are x equals 6 or x equals -1. But if we go back up to the restrictions, we see that x is not allowed to be 6. The reason is if we plugged in 6 in this first denominator, 6 minus 6 is 0, and 1 divided by 0 is undefined. So that is not allowed. X equals 6 is extraneous. That's that word again. It means it's something that looks like a solution but doesn't end up working. And so we throw that away. And then the other solution is allowed. There was nothing saying that x couldn't be -1. So in this case, this ends up being our only solution. And so our final answer is x equals -1. One thing I want to point out for the curious, sometimes students ask, why do we solve an equation and we get something in the end that looks like a solution but ends up not working in the original equation? That's something that up until this point we haven't really seen before. And the reason that that happens, the step that's problematic, ends up being the step where we multiply both sides by the LCD. A long time ago, when you learned the rules for how to solve equations, called the properties of equality, there was a rule that said we may multiply both sides of an equation by the same non-zero quantity. And the important word here is non-zero. It's a word you heard once several months ago, and this is the key to everything. We know that if we multiply both sides of an equation by 0, that ends up making both sides equaling to 0, and we've basically lost all the information we originally had. Well, in this problem, when we multiply both sides by x minus 6 times x minus 2, technically this thing that we're multiplying by, it could be 0. Because x is a variable, x could be pretty much anything we want it to be. And in this case, if x is 6, for example, then 6 minus 6 gives us 0. Or if x equals 2, then 2 minus 2 equals 0. So under certain circumstances, we have effectively multiplied both sides by 0, and that is what causes the glitch in the matrix that gives us a potential answer in the end that is not a solution to the original equation. So anytime we are multiplying both sides of an equation by something with a variable in it, we have to be a little bit careful that we have caused a problem like this that gives us an extraneous solution. And that's that.